Hello, hello, ladies and gentlemen. I hope you're all doing well, and I hope you're all excited for question number 20, the last question in B part on our 2009 Fermat paper, the Fermat paper we've been going through for the last little bit. Okay? So, what have we got in store for question 20? In the diagram, the circle and square have the same center O and equal areas. Okay, the circle has radius 1. Well, if I know the radius, I can get its area, and if it has the same area as the square, I could do things like get the square's side length or perimeter or something like that. So circle has radius 1 and intersects one side of the square at P and Q. Hey, the same P and Q shown down here. What is the length of PQ? Okay, so let's copy this picture into our notebook. I'm going to draw the circle first, because if you've watched any of my videos, the circles tend to backfire. That's not a bad circle. And then we'll just draw, a square that deals with it. Or moves around. Okay, there we go. So that's good enough. So there's O, and then we've got P and Q here. So P and Q are on my circle, and so I could connect them. Let's use some color. I could connect them up to my center O. And now I get a nice little red triangle, and it's going to be isosceles because both of these are sort of length 1. So both of these sides, they're radii, so they're length 1. Now, how could I figure out PQ? Well, things might start spinning in your head. Plan of attack is always a good thing. If, for example, I knew this angle, cosine law would work out great. But since it's an isosceles triangle, if I drop a perpendicular here, and I knew the height of this perpendicular, which I'll work on getting, but if I knew that, then I could use the Pythagorean theorem to get P to that middle point, and then that middle point to Q, and add them up, so just twice the length from P to the center there, or P to the intersection with the altitude. Twice that length will be all of PQ. But, of course, this rearranges, just like saying, if I wanted to use the cosine law, I'd need that angle. Well, this supposes that I need this H. Okay? But this H isn't going to be that bad to get, because we've got a nice little right angle here, drop some more right angles. We get a rectangle here, and H, it turns out, is going to be, because O is the center of the square and the circle, H is going to be half the side length of my square. And I know the area of my square is then going to be 2h, the side length, squared, and that's going to be 4h squared. But I also know the area of the square is the same as the area of the circle. And they tell me the radius of the circle, so pi r squared, so pi 1 squared, or just pi. Okay, so pi is equal to 4h squared. Now, before I rearrange and solve for h, let's see, how am I about to use it? Well, I need the other part, the other leg of my right angle triangle here. So PQ is twice this length, and that length is the square root of 1 squared, the hypotenuse, minus the altitude squared. So I don't actually need h, I just need h squared. That's going to be pi by 4, so I'll get 2 root 1 minus pi by 4. Okay, got a nice exact answer, and then what are the possibilities? I don't see it anywhere in here. Rats. Okay. So what could I do? Well, I've got to sort of make my answer look a little more like their answers. 2 and then 1 minus pi by 4. What could I do? Well, I noticed there are no fractions in their answers, so here's what I'm going to do. I'll get 2 root 4 over 4 minus pi by 4. That's 2 root 4 minus pi, and then I can take out the quarter at the cost of dividing by 2. Why is that? Well, let's do a little intermediate step. I know it's close to the bottom of the page, but we'll do a little intermediate step. We'll get 2 square root 4 minus pi over 4. I can square roots distribute over multiplication. And then what's the square root of a quarter? 1/2. So those guys cancel out. And so my new attempt at an answer is square root of 4 minus pi. Is that one of the answers? There it is. It's A. Just like 19 was up there. Nifty. All right, and that finishes off question number 20. Okay? So, I know from experience when I was practicing these contests, I didn't really care about doing the first 10 or so. But I did care about the last 5, and we're about to get into the last 5. And I also know sometimes 20 or 19 or 18, even 17 can be kind of tricky. So if you're just joining me for question 20, I would encourage you one more time to, not continue on and look at the videos until you've had a chance to actually try the next 5 questions, the Part C questions, provided that's something you're interested in, to really gauge how well you're understanding these things and how far you actually could get on your own on the day of a contest. Okay? But with sort of that disclaimer out of the way, thank you guys for watching, and I do encourage you to, when you're ready, join me for the next 5 questions, Part C, the very end of our Fermat paper. Until then, have yourselves a wonderful day.